Hello everyone, welcome back to Smart Interviews YouTube channel. I am Sumit from Smart Interviews. So today we are going to solve the problems from previous Codechef contest, which is Starters 157. So let's start solving the problems. Now coming to the first problem, non-matching name. Okay, so coming to the problem statement, Alice and Bob invented a brand new algorithm, but they can't decide what to name the algorithm that they have invented. So Alice suggested name SA, which denotes string. And similarly, Bob also suggested the name SB. Okay, so SA and SB are both strings of lowercase English letters. That means it can contain only characters from lowercase a to lowercase z. Okay, so however, Alice thinks Bob's naming sense is really bad. Similarly, she will be happy if the name given to the algorithm is not close to SB, which is given by Bob. Okay, now more specifically, what they are saying is Alice will be happy if and only if the algorithm names does not share any common characters with SB. Similarly, Bob thinks Alice's naming sense is really bad, and he will be happy only if the algorithm names does not share any characters with S, which was told by Alice. So what we need to do is we need to check, is there a way to name the algorithm using only lowercase letters, that is from lowercase a to lowercase z, so that both Alice and Bob are happy. Okay, now if you see the input format, they're saying that the first line of input will contain a single integer t, denotes number of test cases. Next, each test case consists of 3 lines of input. Now, those 3 lines for each test case are, the first line is separated by a space, which are integers n and m, which denotes the length of string A and denotes the length of string B. Now, second line contains string A, which denotes the name of the algorithm suggested by Alice. Similarly, with the third line, string B, which is the name of the algorithm suggested by Bob. Now, what we need to print? We need to simply print yes or no if a valid name exists for the algorithm. If not, we'll be printing no. Okay. So they have also given you the constraints and sample input and sample output. Okay, so there is explanation as well that they have given to us. Now, let's see what is the meaning of this entire problem statement that they have provided. Now, coming to this examples, what they have told us is, so let's consider the first sample input that they have given and let's check how do we got this. So when do we print yes? If there is any other possible name for the algorithm which does not share the common characters from the string A and string B. So let's consider this as string A, this as string B. Now, in string A, what do we have? We have characters D, I, J, K, S, T, R, A. Similarly, for string B, we have B, L, O, S, S, O, M. Okay, now this is the test case that they have provided us. Now, let's think in general. Do we have only these characters from lowercase a to lowercase z? We can have other characters as well, but if I use any characters which are present in these strings that are the names given by both Alice and Bob, will that be a valid algorithm? I mean, they will not be happy, right? They will not be happy. So we just need to check, is there any other characters with which we can name the algorithm? Right. So if you observe carefully, what are the characters that are not present in both string A and string B in between these range? Z is not present. What else? Z is not present. F is not present. And there are some other characters which are not present in this. That means, so it is possible to come up with the algorithm. So that is the reason why the output is yes. Similarly, coming to the next test case, we got no. That means all the characters from A to Z are present in this both strings. Right. If you observe carefully, all the characters starting from A ending till Z, all the characters are present in combination of S1 and S2. Okay, let's say the characters are in S1, the characters are present from A to, let's say, F. Next, in S2, let's say the characters are from E to, let's say, Z. That means, can I say all the lowercase characters are already present in both S1 and S2? That means it's not possible to come up with any algorithm name which is in the range from A to Z, because no matter what character you choose, that will be present in this string. So that is the reason the output is no. Now, how can we solve this problem? There are two approaches that we can solve this problem using what? A counter. And before countering, we can also solve it using a brute force solution. Now, what will be the brute force solution? We'll simply compare all the characters from A to Z, and you will check, is A present in both string, either in string 1 or in string 2. Similarly, we'll do it for all the characters given in both S1 and S2. And if you find any character which is not present in both S1 and S2, you will print yes. Okay, so this is one of the solution. This is next solution. What else can we use? I can also use a set as well. So what should be the type of this set? We need to store the characters. So the type of this set will be character. Okay, so the simple logic for this will be, we'll be taking a set. Okay, we will be taking a set. And what we'll do is, let's say this is a set. Just a second. Let's say this is a set. Now what I will do is, I'll simply include all the characters from S1 and S2. Let's say this is set ST. I will store all the characters present in S1. So let's take the first example. Now I will store all the characters of S1 into this set. Okay. Now next I'll start from the string 2. So as B is not present, I will insert. And I'll insert L, I'll insert O. Then the next incoming element is S. So internally what happens, if S is already present, it won't take another S. Yes, that is the functionality of set. It won't take duplicates. Next, X is present, then it won't take because it's already present. Then O is already present in the first, so it won't take. Next M. So this is how my set will be. Now, how do I know that there are other characters which are not involved in both S1 and S2? Can I count the number of characters present in my set? Now tell me how many characters will be there from A to Z. It's 26. So if the size of my set, if my size of my set is less than 26, can I say that there are few other characters which are not involved in both S1 and S2? So in this case, I can simply print yes. So yeah, this is the idea of this problem. Let's convert this logic into code. Okay, now let's convert that logic into code. So first is we need to take the number of test cases. Then we'll be iterating for the t number of times. Then we'll be taking the size of string 1. Let's take it as s1 and size of string 2 as s2. Okay, next. What next? We need to take the input of two strings. So let's name it as str1 and str2. Okay, so after taking the input, what was the logic that we have came up with? Set. So let's declare a set of type character. Let's name it as st. Now what you need to do? You need to iterate on the string 1 and string 2, and you need to insert all the characters into set st. So I starts from 0, I less than s1, I plus plus st dot insert of str1 of I. Similarly, we'll do the same thing for str2. So just I will be changing the sizes of the string and the name of the string. That's it. Now what do I need to check? If the size of my set st.size, if it is less than 26, there is a possibility of it coming up with a name such that both Alice and Bob will be happy. So I'll be printing yes. If not, if the size of my set is equal to 26, that means we have used all the characters in between A to Z, lowercase characters. So it is no. In the else case, we'll be printing no only. So let's run this and see, are we getting the expected output or not? So the expected output is yes, no, yes. Okay, we got the expected output. Let's submit the code and check is it correct or not. Done. We got the correct answer. So this is all about the first problem. Now let's move to the next problem. Now coming to the next problem, not too far replacement. Problem statement is we are given an array A of length n plus 1 denoted as A1, A2, A3 so on till An plus 1. What you can perform on the array is you can choose an index array which range from 1 to n. Basically they took as 1 based indexing in the problem statement, but in general we'll take it as 0 based indexing by coding it. Such that A of I, that is the element that we have selected, should be less than or equal to twice of the last element. And if that is true, if this condition is true, what you can do is you can swap the values of the current element A of I with the last element A of n plus 1th index. That is, you can swap the element at index n plus 1 with some element of the array that's at most twice as large as it. So you may perform these operations as many times as you can. That means you may perform the operation as many times as you like, even zeros sometimes. And at last, what you need to do is you need to find the minimum possible sum of the first n elements after the operations that they have told you to do. Okay, so we need to find the minimum possible sum of the first 10 elements of A, that means array, after the operations. That is, we need to minimize the value, minimize the first n elements in the array, excluding the n plus 1th element. Okay, so this is how you calculate the sum of the array elements, which is pretty simple to find out the sum. Okay, coming to the input format, the first line of input, as usual, contains the first number of test cases. T denotes the number of test cases. Then each test case consists of two lines of input. One is n, denoting the number of or length of array. Now, the second line should contain how many elements? N plus 1 elements, because we are considering the array size as n plus 1. That means if the value of n is 5, the next line should contain 6 elements. So what we need to print is we need to print the minimum possible sum after performing some replacement operations that they have asked us to do in this step. Okay, so they have given the constraints, they have also given the sample input and output. They have also given the explanation part as well. Now let's see what is the overall understanding from this problem statement, and let's try to get the logic. Then we'll try to convert that logic into code. Now coming to this logic, let's say the value of n is 5. Now how many elements my array should have? 6. Okay, let's say the array elements are 1, 2, 3, 2, 4 and 5. Now what is the sum that we need to find from 1 to 4? So this should be the range of the array to find the sum. Now what is the value of sum here? It's 12. So what we need to do, we need to find the minimum possible value. So for this example, do we have any other minimum possible sum? No, right? So this can be my minimum possible sum. Let's take a different example now. Let's say the value of n is 5 again. Now the array elements are, let's say 1, 2, 5, 2, 4 and 3. Now what is the range of the sum? My range of sum will be from 1 to 4 again. So this should be the value of sum. Now what is the sum of the highlighted part? So if you calculate it, it will be 14. Okay, can I say that this will be my minimum possible sum, or is there any other minimum possible sum? So if you observe carefully, what I can do is I can bring this 3 into this range and I can pull out some element. So what element should I pull out from this range, you can either pull out 4 or 5, but to get the minimum possible sum, we should pull the greater value. So I can simply swap this 5 with 3, but can you swap it directly? Can you directly swap 5 with 3? No, there is one condition that we need to follow. So if a of I is less than or equal to a of n plus 1 into 2, only then you can swap. Now let's check, is it satisfying or not? So is 5 less than or equal to 3 into 2? That means is 5 less than or equal to 6? Yes, it is true. So we can swap the elements. So what I'll do is I'll swap 5 with 3. Now what is the minimum possible value that we can get after doing that operation? We'll be getting 12 now, which is the minimum possible sum. Okay, now let's see for the next test case so that you'll get an idea to solve this problem. Let's say the value of n is 5 again. So the array elements are, let's say 1, 4, 2, 3. Okay, let's take this example. Now the value of n is 3. The elements in your array is 3 plus 1, which is 4. Now, what is the sum that you need to calculate from here to here? Okay, so this is the range of the array. Now, what is the value of sum? 7. Okay, the value of sum is 7. Now, can I minimize this? Yes, we can minimize this. But if you want to minimize this, which value will you swap? You can swap. Okay, first let's see. Can you swap 1 with 3? Can you swap 1 with 3? 6. Okay, I mean this is 6. So which is true. That means you can swap it. But is it making sense to swap 1 with 3? No, right? If you bring 3 here, the value will increase, right? The value of sum will increase, obviously. That means, can you swap 2 with 3? See, the condition is satisfying. 2 is less than or equal to 6. The condition is getting satisfied. But is it really making sense to bring 3 and remove 2? No. But will it make sense if you remove 4 and replace it with 3? That means, is 4 less than or equal to 6? Yes, so this is satisfying, so that we can swap. Okay, so let's swap 3 with 4. Let's swap 3 with 4. So 3 will be here and 4 will be here. Now what is the value of sum? Which is 6, which is minimum than the previous value. So you cannot swap it directly when this case is satisfied. We need to check one more thing, that if the value of, okay, let me write that over here. If the value of a of I, if it is greater than the last value, if it is greater than the last value, okay, only then it makes sense to swap the elements. And this is one of the condition that you need to check. Also, it should satisfy with this condition. So you need to check these two possibilities. If a of I is greater than last value, and if a of I is less than or equal to a of n plus 1. Not take it as n plus 1. You can say it as a of, you can simply say it as last value into 2. Okay, if these both are satisfying, then you can swap the elements. After swapping, you can simply find the sum value. Okay, now let's see one more example. So keep this point in mind. Okay, I won't erase it, but now let's take a different example. Okay, so let me put it somewhere over here. Now let's take a different example. Let's say the value of your n is 3 again, and the array elements are 10, 9, 30, and 1. So range of the sum is this. Okay, now tell me, is it possible to swap any elements? Can you swap this 10 with 1? See, 10 is greater than 1, which is satisfying this value. But is this also getting satisfied? No, because 10 is not less than or equal to 2. This is false. So we cannot swap this. We cannot swap this, we cannot swap this. So this will be my final sum value. Okay. That means there are also few cases where we cannot swap the last value, right? Okay, next. Let's say the value of n is, as of now, don't take any value of n, but let's say the example is 16 and 8, 2, 4, and 1. So the value of n is 4. Now for this example, is it possible to swap 16 with 1? No, because 16 is not less than or equal to 2 into 1, which is 2. So will you stop here? No. So what is the value of sum as of now? What is the value of sum as of now for this highlighted part? So 20 plus 10, which is 30. Is there any possibility to minimize this sum? See, it's clearly not possible that to swap 16 with 1, right? So will you stop the entire process and will you simply print 30 as the sum? So if you observe carefully, we cannot swap 16 with 1, but can I swap this 2 with 1? Yes, we can swap. So if you swap this, your array will look like 16, 8, 1, then 4 and 2. After the first iteration, can you somehow bring 16 to the last step? That means, can you swap 16 with 2 now? We cannot swap. But can you swap this 4 with 2 now? Yes, we can swap because 4 is less than or equal to 2 into 2. So we can swap this. Now, after swapping, your array would look like this: 16, 8, 1, 2, and 4. Okay, now this is the range of the array to calculate the sum. Now, can you swap 16 with 4? Not possible. But can you swap 8 with 4? Yes, possible, because 8 is less than or equal to 4 into 2. So what I will do is I will simply swap 8 with 4. If I do that, my array would look like this: 16, 4, 1 to 8. Now, coming to this step, this is the range of the array that we need to calculate the sum. Next, tell me, can I swap 16 with 8 now? It is possible. So we'll simply swap 16 with 8. So the final array would look like 8, 4, 1, 2, and 16. Now what is the value of the sum of the highlighted part of my array? So the value of sum here is 50, which is very less than 30. So now what did you observe here? How did we swap 60 with 1? Indirectly, not directly, but indirectly. So we first started with 2, then we started with 4, then we swapped with 8, then we swapped with 16. So my array should be in sorted order first to achieve this operation. So what are the things that you have observed till this discussion? One is we need to sort the array. After sorting, when should I swap? Only if a of I is greater than the last value, and if a of I is less than or equal to last value into 2. Only then we can swap what? A of I with last value. That's it. This is the entire observation we did. First step of your input will be taking test cases, then looping it for t number of times. Then you'll be taking the size of the array, which is same. Now, what I will do is I'll be taking an array of size n itself as of now. After that, what I'll do is I'll be taking the first n numbers or first n elements of my array, which is kind of regular input of the array. Okay, now what I will do is I will be taking one value, or what you can say is you can say it as last value, and you will be taking the input of this last value. Okay, now what I will do is I will be sorting there. So basically, you are sorting the first n elements of the array by leaving the last element. Now you'll be getting some value. Let's say it is 0 initially. So you'll be looping from 0 to I less than n, I plus plus. Now, when will you swap the elements? Only if a of I is greater than the last value, and that if a of I should be less than or equal to last value into 2, only then you will swap the array element with the last value. Okay, after completion of the entire iteration on the array, what you need to do, we need to find the sum of the array elements, that is sum of the first n array elements. So sum equal to sum plus a of I. Then we simply print the sum in a new line. So yeah, this is what we have came up with the logic, and we have simply converted that into code. And let's see, are we getting the expected output or not? Yeah, so if you observe, the output was matching. So let's submit it and check, is it the correct approach or not. Done, we got the right answer. So yeah, this is all about the problem called not too far replacement. So now coming to the next problem, small, smaller, smallest. It's a nice name. Now coming to the problem statement, you are given a binary string s of length n. Now what you can do is you can perform two-step operation on this given string. So one thing is you can choose a non-empty contiguous substring of s. Then if the substring contains an odd number of ones, what you need to do? You need to delete every zero in it. If it instead contains even number of ones, you need to delete every one in it. In it in the sense, in which string? In the substring that you have considered. Okay, so in the substring, you need to count number of ones. Okay, if number of ones are odd, you need to delete every zero in that substring. If the number of ones are even, you need to delete every one in the substring. They have also provided you with an example. Let's say s is equal to 1010001, which is a binary string. If you choose the substring from here to here, now how many ones do we have? We have even ones, two ones, so which is even number. So delete every one, the substring that you have generated. So if you delete ones from the substring that you have generated, this one and this one will be gone, and the resultant string will be 0000. Instead, if you have chosen this substring, what would happen? The number of ones is 1. The number of ones is 1. It is odd. So you can delete all zeros from this highlighted substring. So now your string would become 1011. So you can perform these two steps of operations as many times as you like. But at last, you need to find the minimum possible length of the final string. Okay, so they have given you input format, which tells you the first line will, as usual, contains t, which is number of test cases. Then in each line of test case, you have two lines of inputs. One is n, which is length of a string, length of a binary string. And the second line contains a binary string, s of length. So output format, you need to print minimum possible length after performing several operations. Okay. But at last, you need to print the minimum possible length of string s. They have given you the constraints, which contains only zeros and ones in your string, obviously because it is a binary string. Now, think in general, by looking at the constraints, the value of n is 10 power 5. So to generate substrings, it will take n square time. But is it possible to solve this in terms of n square time complexity? Not possible. Now coming to the logic part, let's try to figure out how to solve this problem. So what are the main things that we have analyzed from the problem statement is, you will be giving a string. To be more precise, you will be giving a binary string. Okay, now, so you need to take a substring, non-empty substring. So you need to take a substring, and what you need to do is you need to count number of ones. Okay, you need to count number of ones. Now, depending on the value of count of ones, so if count is odd, what you need to do if count is odd? You need to delete all zeros in the, okay, let me represent it like this. Let's say this is substring. You need to count number of ones in the substring. So if count is odd, you need to delete all zeros in the substring. Similarly, if the count is odd, what you need to do? If count is odd, what you need to do? You need to delete all zeros. Similarly, if the count is even, if count is even, what you need to do? So yeah, let me write it here. If count is even, you need to delete ones in substring. So this is what we have identified or analyzed from the problem statement. Now tell me, when can you delete anything in a string? If you observe this entire analysis, when can you delete anything in the string? Once. If we have ones, so our main focus will be on ones. See, first step is clear. We need to count number of ones. Okay. Now, if it is odd, we'll delete zeros. If it is even, we'll delete ones. Okay. Now, what I'll do is, let's say this is a string. This is a this is a binary string that you got. Can you delete anything from this string? No matter what substring you choose, no matter what substring you choose, you cannot delete anything in this because you don't even have ones. So if you won't have any ones, you should simply print the length of the string because deletion is not possible. Next, let's say the string that you have given is this. Now tell me, what is the minimum possible length of a string after deleting everything? So let's say I have chosen this substring. Oh, it's better if I highlight this. Let's say this is a substring that I have chosen. What is the count of number of ones in the selected substring? 1, which is odd. So what should I do? I should delete all zeros. Delete zeros. I delete zeros. Now this is the string that I have. Right. Next, what I will do? Let's say I have selected this as my substring. Let me highlight the substring. This as my substring. This as my substring. Now, what will happen? I'll delete all zeros. Okay, so this will be gone. This is one. Now, I have even ones. What should I do? I'll delete all ones. So the possible minimum possible length of my string after doing all the operations is 0. That means we got empty string in fine. Okay, now what was the original string that we took? We have zeros over here, we have zeros over here, right? That means if I have even number of ones, if you have even ones in the entire string, not only consecutive, let's say we'll be having a string like this which have even ones but which are not consecutive. Let's check, are we getting empty string or not? See, at last our main aim is to minimize the length of the string after doing all the operations. So I'll select this substring. So we have odd number of ones. So I'll delete all zeros. So after deletion of all zeros, what do we have? We have this string. So I'll select this substring. And what I will do? I'll remove this. So now we have this this string. So now we have the entire string which is having even ones. So if no matter what, if number of ones are even in your string, it will be 0. So if count of 1 is even, you will have 0 as your answer. Now let's take a string with odd ones. So let's modify this itself. Let's say we have 0, 1, 0, 0, 0 over here. Now let's check what should be the minimum possible length that we can get. So let's say I have selected this, so this 0 will be gone. Let's say I have selected this, so this 0 will be gone. Let's say I have selected this substring, so these zeros will be gone. Let's say I have selected this substring, now this zeros will be gone. Now let's say from here, observe carefully. If you select this substring, any possibility of deletion? Because one is odd, so no zeros, no deletion will happen. Here, what happens? The count of one is 2, which is even. So I can delete what? Once in the substring. So I'll delete this. Now you are left out with a single one. Now can you delete one if the count of one is odd? No. So what is the minimum possible length of the string? It is 1. So if count of 1 is odd, we'll print 0. That means, can I simply print count of 1 mod 2? That's it. This is the observation that we have came up with after performing few operations. Now we also covered the edge case as well. If the count of 1 is 0, 0 mod 2 will be 0, but 0 is not the correct answer. Because if ones are not at all present, deletion is not at all possible. So we'll simply print the size of string or the length of string. Okay, so this is the entire observation that we have found in the given problem statement. Now let's convert this logic into code. Okay, so the code now will look like, we'll be taking the test case first. Okay, what to call it? So we'll be looking for t number of times. Then what is the input format? Size of the string. So first let's take size of the string s as SLC. Now next we'll be taking the string str. So str. Now what is the logic that we have come up with? We need to count the number of ones. So we'll take a variable which stores the ones count equal to 0 initially. So we will iterate on the string, starts from 0, I less than s, I plus plus. If str of I is equal to 1, we will increment the value of ones count. Okay, after calculating the ones count, what I'll do is, if ones count is equal to 0, is there any possibility of deletion? No. So we will simply print s as my output. Else, I'll do ones count. Okay, I'll print just a second. In the else case, what can I do? I'll simply print ones count modulo 2. That's it. Now let's run this and check, are we getting the expected output or not. So the expected output is 011 and we got 011. Let's submit it and see. That's it, we got the correct answer. So yeah, this is all about this smallest problem. So yeah, that's it from my side. I hope you learned few things from this video, and make sure to subscribe to the YouTube channel so that you will never miss an update. Thanks, bye everyone.